Hi everyone, I'm going to present about different encryption techniques used in IT. First, what is symmetric encryption? Also known as private key cryptography, it uses the same cryptographic keys to encrypt the plain text and decrypt the ciphertext. The key must remain secure. Examples include substitution, one-time pad, stream cipher, and block cipher. Caesar cipher is a type of substitution technique where each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. The shift value is in the range of 0 to 25. When the key is unknown, we could use an exhaustive key search, drawing out 26 possible keys to find the message. As an example, if the shift is 2, A will become C, D will become F, etc. Here's another type of substitution, random permutation, where the key is any permutation of letters instead of a shift. The number of possible keys is equal to 26 factorial, which is why this is called the least simple substitution. Picture is a particular permutation of the plain text to produce a ciphertext. One-time pad is yet another symmetric technique. Here the key is a string of bits with the same length as the plain text. To encrypt, the plain text is stored with the key to produce the ciphertext. To decrypt, the ciphertext is stored with the key to use the plain text. Moving on to stream cipher, where the original key is a small random string which is transformed into a key string. It is then used as a one-time pad, so you store with the plain text. Here, we no longer achieve perfect secrecy as the one-time pad, since the key is shorter and thus can be guessed more easily. Next is block cipher. Instead of encrypting one bit at a time like stream cipher, we encrypt a block of text. I want to mention about cipher blockchaining, which is a method to increase the security of block cipher. An initialization factor is applied to the first block so that identical messages encrypted on the same day do not produce identical ciphertext. Second, we apply the ciphertext from previous block to the encryption of the next block so that we can ensure identical blocks of plain text are not encrypted to identical blocks of ciphertext. Now we move on to asymmetric encryption. It makes use of two keys, a private key and a public key. The public key is used for encrypting, while the private key is used for decrypting. For instance, the sender could be an IoT device, the receiver could be a cloud server. Another scenario, the sender is a web browser, the receiver is a web server. So how does asymmetric key cryptography work? First, the receiver, represented as a server in the picture, generates a pair of public and private keys. It then sees the private key in red and sends the public key, the green one, to the sender. Next, the sender, pictured as a laptop web browser, encrypts the message hello using the public key and sends the ciphertext to the receiver. Finally, the server uses the private key to decrypt the message. RSA is one of the first public key crypto system and used for secure data transmission. Here is how the system operates the encryption. First, we choose two distinct prime numbers. Next, we compute their product, which is called the Euler-Toschen function, equal to p minus 1 times q minus 1. To continue, we choose any number between 1 and 20, that is co-prime to 20. Let's choose 7. The public key will be 33 and 7, which a server will send to a browser. The browser then encrypts a message using this public key with the formula. The message m to the power of e mod n. To compute the private key, we find a modular multiplicative inverse of e mod 5 of n. To decrypt the message, a server will apply the formula, the ciphertext, to the power of d mod n. Let's now compare symmetric and asymmetric encryption. First, in terms of key size. For symmetric, the key is smaller. For asymmetric, the key is longer. In terms of speed, symmetric encryption doesn't require as many CPU cycles, so it's generally faster. Next is the security concerns for key distribution. For symmetric, because the same key is used for encryption and decryption, we need to get the key to the recipient in a secure manner. Else, anyone who gets a hold of that key can simply decrypt the file. Distributing the key is even more challenging in the case of file transfer over a vast area. This is not an issue for asymmetric. We only need to keep the private key secret to decrypt the file. And we don't have to worry about the public key distribution since it is used for encryption only. The next topic is hashing. So how does it work? It creates a fixed site signature, also called a hash digest, for a message of arbitrary size. The avalanche effect is referred as a characteristic of hashing, in which small changes in input will lead to significant changes in output. Next, we will discuss about hash collision. This happens when different outputs are hashed to the same input. How often will a collision occur? For a 128-bit hash, there are 10 to the 38 possible values, so it will take quite a while to find two identical hash values. Well, given that the algorithm is properly designed and generates hashes that spread evenly. Hash functions will have the following properties: compression, efficiency, one-way, weak collision resistance, and strong collision resistance. Some examples of hash functions are MD5, which produces 128-bit hash values, and SHA-2, which is a set of hash functions that produce hashes of various sizes. Let's now compare hashing with other encryption methods. Well, hashing produces fixed site output no matter how big the inputs are, and it's a one-way operation. For symmetric, asymmetric encryption, the output has the same size as the input, and there are two-way operations. Now we move on to some applications of encryption. First is password hashing. When a user creates an account, the account is hashed and stored in the database. So the plain text password is never written to the hard drive, so it is protected even if the database is compromised. When the user attempts to log in, the hash of the password they enter is checked against the hash of the real password retrieved from the database. If the hash is met, the user is granted access. Actually, password hashes can be cracked by lookup tables. The hackers will pre-compute the hashes of the password and store them in a lookup table data structure. Later, they will look up a hash and find the message if it is in the database. However, a method called sorting makes it impossible to use lookup tables to crack a hash. We will append a random string to the password before hashing, so this makes the same password hash into different strings. To verify a password, we store the salt along with the hash in the user account database. Another application of encryption is found in secure file transfer protocols, which employ hybrid crypto systems. Some examples are SSL and SSH. So here is how it works. First, a server sends a public key to a browser. The browser then uses this key to encrypt a session key and send that to the server. The server receives the session key and decrypt it with the private key. Then both of them use the session key to encrypt and decrypt the files exchanged within that session. As a conclusion, we will discuss the importance of encryption in IT. First, encryption has facilitating secret communication for militaries and government. A famous illustration is Zimmerman telegram. Encryption also plays a crucial role in business, so it helps conducting secure, encrypted transactions online. Finally, hashing ensures integrity and authentication. To sum up, this presentation has introduced the concept of symmetric, asymmetric encryption, hashing, password, secure file transfer. Thank you for watching.